So very good morning once again. Okay. So today, that's Monday, we have started with Unit 2, Process Management, and we have discussed what is the process, how the process it will work, how it will be scheduler. There are three types of scheduler. One is a long-term scheduler, short-term scheduler, and medium-term scheduler we have discussed. Then we have various operations on a process. You can create a process like fork, you can exit a process, you can make the process sleep. Okay, for example, sleep command you have executed in the lab experiment. That was the last experiment we have practiced in the lab on Monday, if you are remembered. Okay, these are all operations on a process. Okay, so up to the operations only we have discussed. We didn't get a time to complete intra-process communication IP. So today we'll start with inter-process communication. Then we will move to the next topic, CPU scheduling. It is a basic some problems of different types. Okay. Now, so these are things that we have discussed. Process is a program in execution. Then how the process it will run. What are the different states? As I said, it is important to remember: new state, running state, waiting state, ready state, terminate state. This is the diagram. If there is any new process, it will go to ready queue. If it is ready to run, it will start running. In case while running, it needs some input to get. For example, if you want to add two numbers, enter the value of A and B. So it is running. So enter the value of A and B. Now it gets stopped because it need the input for A and B. So what it will go, it will go into a waiting state, and it will request for the user A input for A and input for B. So after getting the input, once again it will go to ready state, and it will start running the state. Then it will get terminated. Okay. So this was the work done by the process. Then each process have a process control block. The process control block consists of these following informations. Next, how the process it will get run is, once it will start, if the process initiated, it will save the details into PSB. It will be start running. So in case if it waits for some other input, means it will go to ideal state, and next process, whichever there in the ready queue, it will be start executing. Once this process goes to waiting date, some other process it will come and start running the instructions. So then thread is a single weight process, a lightweight process. Each process have multiple thread. Each process may have multiple operations. Okay, so likewise it will be keep on switching. This is the process ID and state of the process. Likewise, these informations that we have discussed in a last class. There are three types of schedulers. Okay, not scheduling, schedulers. Short-term scheduler, long-term scheduler, and then medium-term schedulers. Then another important tool mark, as I said, is context switching. So context switching is like if a process switching from one CPU, process switching from one state to another state. Okay, then the existing state should be saved, and then only you can able to move it. Okay, so when CPU switches from one process to another process, the system must save the state of the old process, then only it will load into a new process. Okay, then this thing we have discussed. Then process operation like creation, termination, these things that we have discussed. So likewise we have discussed the basic programs. So now we'll start with inter-process communication. So process within a system may be independent or cooperative. For example, what is inter process means? If a process it needs to run means it need to get some information from some other process. Both are like it will be both they need to coordinate with each other. Okay, even though it is an independent, or even though it is an independent, it needs some communication from some other process. So both the process may cooperate each other, then only it will be working. So that is called as inter process. A processes within the system may be independent or a cooperative. So the cooperative process can affect or to be affected by other process, including shared data. For example, the two persons are working in a project. For example, two process or two persons, they are working in a project. For example, a process one need to provide some output in the middle of the work. So then only process can to take that input or that output to do the process. So there are two process or two persons doing a job. So consider P1 and or P0. It is a process. It is a process, and P1. It is a one process. So both the process are doing a job. Both the process they are doing a job. So P1 start doing a job. P2 also start doing a job. At some stage, P0 need to communicate to P1 to provide some output, or P1 need to communicate with P0 to provide some output. So what will happen is both it need to cooperate. Both it need to cooperate each other to get. So a cooperative process can affect or can be affected by other process, including some data. He will be sharing some data to P0, data to P1, and P1 will share some data to P0. So likewise, both the process share some data in it. So what it will be doing for cooperating process, either the information sharing, or they will computational speed up, modularity, and convenience. In whatever the way they need to share, they will be sharing. But here we are considering two things in inter-process communication. One is sharing the memory, shared memory, and message passing. Two things that we are going to discuss in inter-process communication. So inter-process communication is cooperating the process to complete a particular job. So how they will cooperate? Either they will be using a shared memory, or they will be passing some messages. Passing messages means data will process from P0 to P1. Okay. So this is the way the communication model happens. So both the process, it is available in a ready queue. So both the process, it is available in a ready queue. Okay. First one is message passing. For example, this is the ready queue. Ready queue. So queue means the process whichever is requested, it will be allocated and running. So first one we are going to discuss about message passing. So this is the ready queue. So a process P is running and process B is running. So what will happen is the process A need to access some messages, process B need to access the messages. So both they will not directly transfer the informations. So what happens is process A transfers some message into a message queue. So this is the message queue, M0, M1, M2, M3, Mn. These are the message queue. So once the process PA passes some messages, process B passes some messages, both they will accept the message, or the process A passes the message from the message queue, process B it will take the message. So vice versa it will be happening. So in a common message queue, it will go and take the information which is available in it. Okay. So this is called message passing. Second type of communication model happens in inter-processes, shared memory. So shared memory is you have a common memory. You have a common memory for both the process. The process A shares this memory. Process B shares this memory. So with the help of kernel, all the operation will happen. Here also you have a kernel, or with the help of kernel, everything happens because you are running the process in the kernel. Okay. So what about independent process? What about cooperating process? So independent process, it will start running without or cannot affect the another process. So if you need an input, it will take initially, or it will take from somebody else. It will not interact with any other process. An independent process cannot affect or to be affected by the execution of another process. But in case of cooperative process, it will be affected or be affected by the execution of another process. What is the advantages? Information, speed up, and modularity and convenience. So best example is producer-consumer problem is an best example for your inter-process communications. Okay. Before going for inter-process communications, I will I just an example I will tell you. For example, you are at home. Okay, you are in home, or for example, your mother is preparing. For example, some snacks like bhaji or something you can call some evening snacks. See, she is preparing from a bowl. This is the bowl. Shows your mom is preparing something with the flame. You have a flame. So your anybody else or mom, whoever it may be, you are preparing a food. Okay. Some snacks, something she is preparing. So consider this as a buffer. Buffer means the plate or where after preparing she will put the snacks in this. Then you people, you will be taking in your plate. So this is your plate. It is a bowl or a buffer. So if she is preparing evening snacks, so here she is using a vessel with oil. She is preparing some snacks. Okay. So what happens is, like, you are here, you are waiting with a plate. When she is preparing the snacks in this oil vessel, okay, oil vessel, you cannot able to take it. You cannot able to take because it is a producer. He is a producing, mom or she is a producing. Mom is a producer, you are the consumer. You are going to take and have. So while producing the producer, this is the process. While producing the producer, you cannot able to consume that. So when you can able to consume, after she take the snacks and put into the vessels, like small snacks or like finger chips, something like that. After she put into this bowl, okay, after some few minutes or within some 10 to 20 seconds, she will you need to wait because of hot you will not take. Then what you will do, you will be taking the snacks in your plate and you will be start having. So consider this is the process. This is the process P0, producer. You are the consumer. So process P1 is producing the items. Until that process P1, you will be wait. Once the process P0, it holds for some time. After holding it, what will happen? You will start consuming it. So while you consuming this buffer, it will get empty. Your mother start once again. She will be start preparing it. So what happens when the producer is producing? You will be waiting. When the producer is producing, you will be waiting. Okay. Once the producer has produced the item, okay, what you will do? The process P0, you will be start consuming. So at the same time, she will wait for oil boiling. Then once again, she start the process. So that is called as an example. I'm telling producer-consumer problem. If producer is producing a data, during that time, you cannot able to consume because the buffer will be empty. Once the producer is release the buffer, once the producer is telling some product is produced, then only the consumer can able to consume the data. So you have unbounded buffer place, no practical limit on size. You have bounded buffer, assume that it is a fixed buffer size. So first what we are doing is you are defining a buffer size as 10. The buffer size is 10. So initially the buffer is 0. Initially the buffer is 0. It consists of, it can able to hold 10 data. So how this 10 data can be used is, this is the producer P0 and consumer is P1. So once the producer is producing the data, he will be loading the data 1, 2, 3, 4, something is loading. After loading, what you will do as a consumer, you will be start consuming this data. You will take 1, 2, 3 or 4, 3, 2, 1. So while taking itself, the producer has an ability to hold, put some other numbers. After putting this, after he will block the bowl and block the buffer, and he will add the items. After releasing that, the consumer, it will be start consuming. So initially the buffer size is empty. Sorry, size is 10. Initially the buffer size will be like empty. Nothing is in, nothing is in, nothing is out. So then what you will do until, okay, while in plus 1 mod buffer size, until the buffer size is getting full, or until the items is produced. While true produces an item in the next production, he will be producing, he will load the data until the buffer size. Then after loading, what it will do, the consumer, it will be start consuming data. How you will consuming? Until the output is empty, until the buffer is empty, you will be start consuming data, consume the items in the next. Each one by one, it will be start consuming. So this is the inter-process communication where the common shared memory is used. The buffer is there, you will be using a shared memory to complete the process. Okay. So then how the message passing happens? So message passing is two things that you will be communicate or synchronize with the things. That is, one is you can send the information. Another one is you will be receiving. So sending information and receiving information, it will be happen in a sending information and receiving information. It will be happen when you are communicating with a different process. So which helps you to inform that a process completes the work, or the process is doing some work. Like that, you will be sending the information and you will be receiving the information. Okay. So message passing link. So for example, there is a two process. One is a P, another one is a Q. Okay. So both, they are using some common shared data. So what will happen? This process, it will hold the resource. Okay. So this resource is held by P. So once what it is happening is the Q is requesting for this resource. This is the resource. Either it may be input-output resource or CPU, something, it is there. But this process is holding. So when the process Q1 is requested, okay, the resource is not allocated because it is held by P1. So what will happen is once this resource is completed, P1 sends information, or the CPU sends the information to Q that this resource is free. Then this resource is allocated to Q. So the process P and Q wish to communicate, they need to establish the communication link between them, exchange them via message send and read. So one is you can do a communication with the CPU, or you can do with the process P and Q, each other they can send and they can receive the information. Okay. So this can be done by using a message passing. So in message passing, they can share the memory, they can share the hardware bus, they can use network. So in the logical way, they can directly communicate, indirectly they can communicate, they can do a synchronization communication and asynchronous communication, automatic explicit buffering. So how the direct communication is happened is send P comma message. Send P comma message. So it will send a message to P. Receive Q comma message. It will receive a message from P. So it is a simple way transactions they can establish. So to whom it want to send. So this is to whom it want to send, from whom the message is coming. So this is the information about P and Q. So the particular message, create, open, for, close, all these informations are communicated. So properties of communication skill is like links are established automatically. Link is associated with exactly one pair of communicating process, and the communication happen within each pair and exist in one link. The link may be unidirectional, but both in a form of a bidirectional. So both they can communicate with each other. Another part is indirect message. Indirect message, what they will do is they will send the information or receive the information through mailbox. They will not directly communicate. Messages are directed. Messages are direct and received from the mailbox, also referred to as a port. Each mailbox has a unique ID. They will be passing into the mailbox. From the mailbox only, they will be taking it. So this is indirect communication. So this is established in a common mailbox, and the link will be shared. Several communication may happen. So both this is also unidirectional or bidirectional. Okay. So you will be having a new mailbox. From this new mailbox, you will be communicating with the system in an effective way. So here are send to A, receive from A. Same way you will be doing, but only you are mentioning that mailbox, A as a mailbox, not a process. Here you are using a process. P and Q are a process in direct communication. Here you are using A to receive and send. So both are in a form of a mailbox. Now, for example, there is a mailbox. This mailbox is there. So this mailbox is called as A. So what it will do, the process P1, P2, P3, all these processes will be sharing the common mailbox, like your WhatsApp group or something. Okay, you have a common mailbox. P1 sends, P2 and P3 receives. So P1 is sending, P1 and P2 receives, and P2 sending, P1, P3 receives. To whom you want to send, everything that you can mention in it. So that is an indirect communication by using a common common communications. So whenever you are doing inter-process communication, you need a synchronous. Synchronous means both should synchronize mutually. Okay. So message passing can be either done by a blocking or unblocking. So blocking means when you are accessing some information from the buffer, somebody should not write it, or somebody should not change the value. So you will be blocking the buffer and then you are using. So another way is unblocking. Okay, simple example I will tell you, blocking and unblocking. For example, okay, this is the buffer. Buffer is a storage device where you are going to store some data. So if I asked you to do some work, okay, for example, if I asked you to write some work and then write some assignment, okay, if your friend is asking without writing or while writing, you cannot able to give him. So if I'm asked you to write some assignment, if your friend is asking, or if I request all to write, somebody will start writing by your own, somebody will copy. So what will happen? Blocking is like, if your friend is writing P0, it is a process. So it is a P0, it is a process, and one more friend is there, he is a P1. So what will happen? P1 is, it will block the paper, or he will block the paper. He will complete all the work in the assignment. Okay, all the work. So blocking, he will block that, he will not share that. So once he completed, then only he will send the assignment to the person P1. Then person P1, he will write and he will host. For example, blocking is considered as synchronous. Blocking, sender is blocked until a message is received. Sender, he will block the content or information in the buffer. Once he completed, he will send the message. That is a blocking receive, that I have completed, you can use. Non-blocking is like, both together they can write at a time. For example, if you are together, if you are writing, both, what you will do, both at a time you will be start working. So unblocking is, they will not block the data, they will send the message and receive the message continuously with valid input and valid message. So this is the example for producer consumer problem with synchronous. So producer consumer problem, the producer, he will be producing consumer will be consuming when the buffer is full. So when the consumer can consume the buffer is when the buffer is full. When the producer can produce is when the buffer is empty, then only they can able to produce. So while true, produce an item in the next producer. So he will be producing all the items. Message to be consumed. While true, receive or next consume. So you will be receiving this information. Now the buffer it will be empty. So once again, producer start producing the items. He will block this. Then consumer he will be start consuming. Now the buffer will be empty. So this is the synchronization part. So buffer may be a zero capacity, or you can fix bounded or unbounded capacity. It's up to you. Okay. So these are all the concept behind your IPC. Now we'll see small example of POSIX shared memory. So this POSIX shared memory helps you to share the informations or share the some of the shared memory segments. So you have a segment. This is the shared memory segment. You have a number of message queues or blocks. Something is there. You have a number of data in it. Okay, you will be having a data inside. You'll be having a data. So the process first create a shared memory segment. So I have created segment. These are all segments I'm divided. So then shared memory file descriptor. So you will be having a file descriptor data text, for example, data.txt. So it is a text file. Data.txt, you have a text file. So what will happen is, if data.txt, so you are going to open the file name, you are going to create, and you are going to perform RD. RD is for read, W is for write. So you are going to read and write in a particular file. So you are going to create and you are going to do it. So once if you are completed the work in it, so you have loaded the data 1, 2, 3, 4, 5, 6, 7, 8, likewise you are keep on loading your data. Once loaded, you will be providing an object with a truncate, the size is 4096. Then you will be start sharing this. You will be start sharing the information on it. So you can share to any other process. It is a sample program in a C. So once the object is written, you are going to mention the size of the object and you are going to share. So these are all the experiments we will be executing in our lab programs. Okay. So this is the producer, he is producing items. Consumer, he is consuming these items. So consumer can able to only do reading, they cannot able to write. Consumer, they can only do reading, they cannot able to write. Okay. So that is one example. Second one is Mac. So Mac is a communication based methods where it helps you to send the message, receive the message. There you can do a direct information send or receive. You can do open name, shared memory. Here they are mentioning message underscore send, message underscore receive, message underscore remote procedure call. So, okay. So this is the another way that you can do in a Mantissa OS. Okay. So in Windows, it is a normal, that's what generally we are doing. So we will be using our local procedure call, like create a socket, open, close. By using a common portal, you will be communicating. Okay, these are all things. Okay, so this is a local communication generally happens. Client request for connection. If the port is available, they will be handled by the servers. Once the handlers are done, then client communication port it will be enabled, where the client can start communication between the server, both the server it will handle. So this is the core part of sharing the information. So from a client to servers. Okay. So once everything is over, all the informations are communicated in a stack. So mutually, the shared section of the object with the informations, can be both the shared section of the objects informations they can share in it. So this part is not there in your syllabus, but for general, you need to aware what is a socket, what is a remote procedure call, and what is a remote method invocation, RMI. So okay, I will explain you only a socket. We'll go to the next topic. Okay, socket is defined as endpoint communication. If you want to communicate between one system to another system, or if you want to send a message from one system to another system, you need a socket. Socket is defined as an end-to-end endpoint communication or end-to-end communication between it. So if you want to communicate, you need a port number. So each system have an IP, and each system that you will be having a port number, or in a particular switches you will be having a port number. So it consists of two things. A socket is defined as endpoint communication. It contains two things. One is IP address and port number. So this is IP address. This is IP address, and this is the port number. So if it has both IP address and port number, then only they can able to communicate. So communication consists between a pair of sockets. So all ports below 1024 well known, used to standard service, special IP addresses that you will be using to communicate between the two or more processes. Okay, this is an example. A host want to communicate to the web server. The host want to communicate to the web server. So he is having a port 16625 and its IP address. He'll be communicating to the web server. Okay, so web server IP address is like 16. They are one web server having one socket, host having one socket. It will mention its ID and port number to the web server. Web server have 8080 port number, 8080. So they will mentioning 80. So it has one IP address. Both the socket it will got communicated in it. So this is the way that we will be doing communication in the net. Okay. So there are two types of connection, one is TCP and UDP. Transmission control protocol, user datagram protocol. These are all things you will be studying in computer networks. This is a basic. Okay. So by using, this is wired communication, this is wireless communication. Transmission control protocol, user datagram protocol. It is a connectionless, it is a connection oriented. Only you are aware of it. That is enough. Okay. So RPC, remote procedure call, is if you want to access some information remotely through network, then you will use a remote procedure call between the process in a network system. So these are all, it is not there in syllabus for your general. Okay. So we'll move with the next part, CPU scheduling. Okay. So this is after process, you have a CPU scheduling. I think CPU scheduling we cannot able to complete today. We will have some two types of scheduling we will discuss. So CPU scheduling. So it is a very important topic in your second unit. Okay, it is one of the important topic, but most important part in your second unit, CPU scheduling. So generally, what is the scheduling is, if a process has some work, the work time is called burst time. Okay, a process it will complete some work in some seconds. Okay, some weightage will be given as a burst time. So within the burst time, how it is utilizing the CPU. So that only we are going to calculate in a CPU scheduling. So what are things that we are going to discuss is mainly we are going to discuss these four parts. What is the basic concepts? Scheduling criteria, scheduling algorithm, thread scheduling, and multiprocess. So this is the core important part, CPU scheduling algorithms. So why you need CPU scheduling algorithm is to get a maximum CPU utilization. So okay, if you are getting a maximum CPU utilization, means you have to effectively use your CPU. That is meant for CPU utilization. If you are using effectively your CPU, then you will be saying that you are using a CPU in an effective way. So which can be obtained by using a multi-programming. If multiple programs run together, if the CPU is available, then the CPU will be utilized effectively. Okay. Next, two things that you have to keep in mind. One is a input-output burst time. So what is the burst time or a burst cycle? Burst cycle is like if you are giving any input, the time of input and time of completion, that is called as a burst cycle. At what time you are entered, at what time you have come out, that is called as a burst cycle, that you have to keep in mind. So a process execution consists of a cycle of CPU execution and input output, right? If you are inserting, if the process is running, it started running in a CPU until it get completed, that called as a burst time. Okay. So this is the burst duration. It is everything we are calculating in millisecond. A process starts at 40th process at 40th frequency. So it goes 140. And then it goes peak of frequency to start doing. Then stage by stage it reduces and it complete its process by 40th millisecond. Okay, it started running, waited for user input, user gave the input. Okay, once user giving, the program is running smoothly until 40 seconds to get completion of work time. So this is the way the CPU burst will happen. First, CPU burst, it will load and store, it will add the store, read the file. This is CPU, it will utilize the CPU. Then if it this file, this process P0, it requires to read the file, what will happen? It need to wait for input output. When it is going for input output, it is called as an input output burst time. Once you are giving, once the user is giving input output, what will happen? It will store the information, store the increment, index, and write the file. This is CPU. Now whatever thing it return or it showed to you on the screen, during that time also the system it will wait. Okay, that is called as an input output. Once again, after writing, once again, if you want to execute or if you want to give, if you want to run the program, once again it will load the store, add store, read the file, CPU burst. Then it will wait for input output. So this cycle repeats everywhere for all the program. This cycle it repeats. First CPU burst, load the content. Then input output burst, wait for input output. Once again, CPU burst, it will store write for the files. Then input output burst, wait for input output. So likewise, it will be keep on working on it. So CPU scheduler is like in two ways that we will be using. So when a process is ready to execute, you need to allocate, or system it need to allocate the CPU for execution. So if multiple processes are waiting, you need to allow the process to run based upon the available of CPU or based upon the waiting time the process that takes. So based upon that only it will be working. So CPU switches running to waiting state, it will switch running to ready state, it will wait for ready state. So the scheduling it takes in a non-primitive. Non-primitive means it will not stop. Keep in mind, non-primitive, it will not stop. Preemptive, what it will do is it will be stop the process. It will stop the process which is already running. Okay, by seeing an example, you will be getting an idea. Okay, so these are things that we are going to calculate. So important thing, kindly listen, we will have only one problem on it. CPU utilization, how the CPU can as busy as possible. What is the throughput? A process that complete their execution per time unit, a process which completes the work per time unit. Next one is turnaround time. Turnaround time is amount of time executed as a particular process, amount of time that you need to complete in a particular process. Next, waiting time, amount of time a process has waited in a ready queue. Response time, the time it takes from the request you have submitted until the response you produce. Okay, so you have 6 definition. So this 6 definition can be remembered, can can be remembered by solving the problem. Okay, so this part you need to identify. So this is the first type of scheduling. The first, only I will complete this one today. Tomorrow, next class also I will revise. This is the first CPU scheduling algorithm. This problem generally in most of the examinations they will be asking. There are 5 different types of scheduling. Among the 5 different types of scheduling, the problem will be asked. Okay. Now the question will be like, there are 3 processes, P1 and P2, and the process has a burst time like 24. It means the P1 it runs for 24 milliseconds or seconds, P2 runs for 3 seconds, and P3 runs for 3 seconds. This is the problem they will be giving. So under CPU scheduling, you have 6 different types of CPU scheduling, 6 different types of CPU scheduling. So first one is first come, first serve. First come, first one, first serve. It means whatever the process is coming in a ready queue first, that process it will be allocated to the CPU. Okay. So for this, what you need to do is you have to draw the Gantt chart. You need to draw the Gantt chart. This is the Gantt chart. You need to draw the Gantt chart. So the process P1, P2, P3 is coming. You need to draw the Gantt chart. This is called the Gantt chart. Okay. Keep in mind. So first P1 is coming. So what happens? P1 is coming. It does not wait for anything. It does not wait for anything. It does not wait for anything. So immediately it starts its work in a CPU. So its arrival time is 0. Arrival time is 0. From 0, it is executing for 24 seconds. For example, you keep in mind 24 seconds it is running. So arrival time is 0. It does not wait for any seconds. It is waiting. It started running the CPU. So running in a CPU by for 24 seconds. Next is P2. The process P2 is coming. When the process P2 is coming, it cannot able to use the CPU because P1 is already executing. So when the P2 can start is P2 can start after 24. P2 can start after 24 only. Now P2 is executing. So 24 is the completion time of P1. So 24 plus 3 is 27. It can able to complete the CPU by 27 seconds. The process P3 is in the ready queue. It need to run, but already P1 and P2 is running in the CPU, so it cannot able to run. So it wait until 27, then P1 it will start. 27 plus 3 is 30. So now this is a simple thing, first come first serve. Whichever the process is coming first, that process you will be allocating to the CPU for execution. Okay. So this is the first come first serve schedule. So what you need to calculate is you need to calculate the waiting time. You need to calculate the waiting time. So waiting time is P1. How much second the P1 is waited for CPU? Waiting time is this. Previous to P1. Okay. Waiting time is 0 because it does not wait for any process to complete. So P1 is 0. In 0 seconds it has completed. Then what about P2? P2 completed its work by 24 and P3 is completed its work by 27. P2 is completed, sorry, P2 is waited for 24 and P3 is waited for 27. So P1 is 0, P2 is 24, P3 is 24. This is the waiting time. This is the waiting time. So you need to calculate average waiting time. You need to calculate average waiting time. So average waiting time is 0 plus 24 plus 23 divided by total number of processes. Total number of processes 3. 1, 2, 3. So 0 plus 24 plus 27 divided by 3 is equal to 17. Okay. Now you have identified the waiting time. Okay. Second, you need to identify the turnaround time. Okay, you need to identify the turn around time. Okay, turn around time. T1 this is called turn around time. So you need to find turnaround time. So what is the turnaround time? Means like at what time P1 is completed plus at what time P2 is completed, at what time P3 is completed divided by 3. So divided by 3. So that is called as total turnaround time. So P1 completed by 24, P2 completed by 27, P3 is completed by 30 divided by 3. So 24 plus 27 plus 30 divided by 3. So that is the average turnaround time. So if your turnaround time is, you have to mention turnaround time is P1 is 24, P2 is like this. Turnaround time for P1 is 24. Turnaround time for P2 is turnaround time for P1 is 24. Turnaround time for P2 is 27. Turnaround time for P3 is 30. And the average turnaround time, average turnaround time is 24 plus 27 plus 30 divided by 3. So that is the result. Okay. So this is the two things that you need to calculate for all the problems: waiting time, average waiting time, turnaround time, average turnaround time. 4 things you are going to identify. Then one more thing that you are going to identify is total turnaround time. What is the total turnaround time? Is when all the process completes its job. When all the processes completes its job is only one answer. All the process completes their job by 30. That is called total turnaround time. Okay. So once again, tomorrow we are having class. Once again, I will repeat the CPU scheduling tomorrow with same problem with some new examples too. Okay. You have 6 different types of CPU scheduling. This is the one which is very, very simple. Okay. So same thing we'll be discussing tomorrow session 2. So don't leave the session. Many of you having arrears today, physics exam. I don't know why you people listen. This time, if you're asking from arrear students, you may aware that the questions no one has shared. Many of the questions are not shared, and the questions are taken from external faculty. For regular exam also, 50% it will be same. So the questions will be from external examination. They will be choosing it. So we will also prepare some set of questions. We'll be sharing that. So it is not confirmed that same questions it will come like previous semesters. Okay, previous semesters like we have because of that first time